Okay, now let me do another short example on illustrating how we can do the sum of complex numbers using these lines or vector representation. Here I have I'm going to take the first number, it's going to be 5 plus I, and if we plot the real part of the number, 5, on the real axis, and the imaginary part, which is just 1 times I on the y-axis, and then we draw the line to that coordinate, that represents the complex number. Same thing over here, we have the number -2 plus 3I. We plot the -2 on the horizontal axis and the plus 3I on the y-axis to give us a representation for that number. And we can represent the sum of these two complex numbers simply as being the sum of these lines, where one line is placed right on the end of the other. So let me try to show that with an example here. Okay, I'm going to cut this out right here and bring it over here, and I put that origin right there. So now I have a new representation, a new vector representation for this complex number, which is this line plus that line, keeping the directions of the lines true to their original direction. And that sum then becomes that line. So that is the sum of the two complex numbers. Another way of using this vector representation, which turns out to be very, very, very convenient when looking at the product of two complex numbers, is to take this representation, this Cartesian representation, and rather than looking at it as an x-coordinate and a y-coordinate, what we do is we look at it as the length of the vector, which we'll call r in this case. Here's the length of that line. And then we look at the angle. Okay, so this angle, let's say, is theta. So we represent our complex number in terms of the length of the line and the angle theta. So we have a representation of the complex number where the following situation exists. Let me erase a space here for this. Okay, where if we look at our Cartesian coordinate pair, and we draw our and we say, here's our complex number, okay, and the x-axis gives us is here, so this gives us the x value, and the y value is written on the vertical axis. So this gives us the y value right here. Say IY, I times y. Instead, the way we can represent the number, instead of as here we represent the number z is equal to x plus IY, we can represent the number using this notation. Now, are you ready? Because this will be something new. We can say that the complex number z can be written as r times cosine of theta. Again, if this is theta, r is equal to cosine theta, which is x cosine theta, plus I times r sine theta. Okay, so that's another way of representing it. Now you're looking at this and you say, well, how is that possibly a simplification? Well, it turns out that it is. And I'll explain more about this later, but let me give you a hint. And that hint is that we can write cosine theta cosine theta plus I sine theta in the following way. We write it as being e, the complex constant e, to the I theta. I'll explain more about this way of representing the number in my next video post.